hello. Thank you, Shmuela. Do you see my screen?
No.
Let's do. Whoo! Now you see my screen.
It's alive.
It's alive. What's alive?
We're alive. I
We
guess.
are alive.
We're on the stage.
In great times where hopefully machine learning can write code for us, or as you will discover soon. So we thought. Shmuela did some spoilers, so we won't go over this again. But Dominic and I met here in Angular Connect last year. We attended a very interesting talk. Do you recognize this guy?
I think I recognize him. If I look very closely, I can see, I think his name is Asim. That's at Angular Connect last year, almost like 1 year ago. And well, it looks like, I don't know, you probably know him from some of the projects he did. Can you remember what that project was about?
Yeah, he showed a lot of exciting demos with machine learning. One of them was, for example, taking a photo and running it through an algorithm that will tell you what the emotion conveyed in that photo is, and then replacing that photo's person's face with an emoji, the emojifier. Worked quite well.
Yeah, it worked well.
And he also had another interesting concept. Can you tell us?
Yeah, so he talked about AI in JavaScript, and there were a couple of examples. But one example that really that we remember well was this form, right? So the goal was to generate an HTML form by just putting in a description of that form. So we could say, hey, we want to have an input field and 2 checkboxes and a radio button and all these things. And then automatically, what's going to happen is it will generate that form for us. Isn't that insane? But guess what happened next?
He released it as open source?
No, not quite.
So
I don't know.
Click the submit button.
Let's do it.
Then YouTube loaded. He fooled everybody.
So I guess we're not here for dancing, but
Right.
This song is called Never Gonna Give You Up, so we're never gonna give up on that. So it's not yet possible, but we're getting there.
Thank you, Asim. Everybody, a big for Asim for inspiring us to do this talk.
Because without him, we wouldn't be on this stage, so we had a lot of inspiration from Asim, so yeah, thank you.
And after his talk, we sat together and started brainstorming. How could we bring this into reality? What could we do? And we had a couple of ideas, like sketching an app on a notebook, scanning it, and generating code out of that. But eventually, we had one idea that clicked.
Exactly, and so we went with this idea of automatically generating code for us. Basically, well, taking away our job, because that's our job, writing code, right? So what we thought is, given a function signature, and that's what we see there, we pass it into this black box that we call model, right? And then we wanted to predict the implementation of this function, and in this case, it's just adding A and B together. So that's what we wanted the model to do.
So basically, given the start of a function, write a function.
Yeah.
And what's the thing in the middle, the model? Can you explain a bit?
Yeah, so this model, we don't have to dive into all the details, but you can think of this model, this black box, as a JavaScript-ish function, which has one input. That could be anything, right? We pass in some input. It does some computational magic. We don't have to worry about that magic. And then it returns an output. That's what this model does.
So basically, it's magic.
It is magic, but the thing is, we don't have to implement this computational magic ourselves. We let the machine figure out the implementation of this function.
So that's what machine learning is all about, getting the content of that magic model function figured out.
Exactly.
All right, so speaking of magic, can you hold this bulb for me?
I can. I don't know what's going to happen.
That's machine learning. Well, it doesn't work.
Machine learning doesn't work.
Yeah, we'll try that again. It's broke. We'll try that again later. Anyway, so...
So you might be like this, right? We've just seen that generating an HTML form from description is not really possible. So you might be like, oh, come on. Stop fooling us. It's not possible. But...
we actually went ahead and tried this, and we gave a talk about it a few months ago in a great conference called NG Vikings. And you will be able to see in a moment what it looked like in that talk. We tried it live, and, well, did it work?
It's a glimpse, so let's have a look. Hopefully the audio works.
Yeah, you were really surprised by the implementation of add. Like, I wouldn't say it's the most straightforward implementation you would come up with.
Well, I can see flush after it kind of subtracts A from B. It could be
adding
numbers.
It's
very creative, I would say.
Well, but yeah, the model got really creative. It did manage to create like valid code, which is quite amazing and very creative indeed. And after this talk, we were excited and we summarized our learning. So first of all, as you probably you just had a glimpse, but we learned that automatic code generation is hard, right?
Right. And also what we learned is that data processing, we talked about this a lot in our talk at NG Vikings, so you can check it out. But data processing, that includes cleaning, gathering the data, and all that, and all those things, that makes up a huge chunk of the work. It is really a lot of percentage of that entire work just focusing on the data, because data is so important for machine learning.
And basically, we really loved working with machine learning. We found it hard, difficult, but fascinating. And we decided to give it another go. This time, we had a different goal, though. We decided to think, what else can we do with code?
I could think of a couple of things. But let's not try to take away our job. Let's try and create this synergy between us and machines.
Like, I have an idea. Do you like to write comments? Like, do you write comments?
Well,
do you people write comments?
I have to, but
Who
I
write
don't like
comments?
It. Who likes to write comments?
Who likes to write them? I see a couple. Oh.
Well, there's someone that's good for you.
Wow. So you can come and work with our machine learning model together. For the rest of us, we decided to try to, again, given a function, this time the entire function, just predict what the comment would be. Have this model function return us the comment for that function.
That is great. I mean, that really makes our lives as developers much easier. So we don't have to document our code. We just have this model which generates the comments for us and summarizes the code. That is fantastic. Does it work?
So we also had another goal before we're going to show if it worked. We decided that this time we're going to use machine learning with JavaScript. Because traditionally, machine learning is done in other languages, such as Python. And then if you want to take your machine learning models and use them everywhere, basically on the web or in Node.js, it's not very straightforward if they are written in Python. Python doesn't run on the web. So we decided to try and use JavaScript this time. We'll tell you about it in a bit. So the general process looks like this. We start by gathering data.
We need a lot of data.
Like?
A lot.
Like how much?
Well, maybe 300,000 thousands of examples, or even 1 million of examples. So it's a lot of data.
And then I see we need to clean it and prepare it. So it's easy for the model to find out how to approach code. And then we need to train the model.
Exactly. But this is basically what we've talked about already at NG Vikings. But for this talk, as we know, we wanted to add this layer of JavaScript to it to make it a little bit more practical for us so that we can consume those. So what we did is we added another layer to this. So taking a trained model, we're going to see what this looks like, and then somehow use TensorFlow.js to consume it in JavaScript.
So TensorFlow, that is a machine learning library for Python, but it has a special property. There are also versions for JavaScript, for Android, for iOS. So a bit like Angular, it's universal. You can run your models anywhere. You can create them in Python, run them in JavaScript.
Exactly. And then once we have it in the JavaScript world, we can then use the tools that we use, such as Visual Studio Code, right, which is awesome. And then we can create an extension for it so that we can consume the model in an extension and then predict the comment.
All right, so let's start with gathering the data. We need, you said, like...
a lot of it.
A lot of comments. So we have like 500 people in the audience. If everybody writes comments for us, how long will it take us? Do you perhaps have a better idea how can we get a lot of comments?
Just fetch
GitHub. Yeah. So, yeah, can you go on GitHub and just download?
Well, I know what I typically do is, well, there's this download button. So I
Yeah.
can just go through all the repositories and click that download button. Can't
like
I?
hundreds, thousands of time. Well,
It's going to take me a while, but sure.
I have a better way to do it. Let me show you. So there is this thing called BigQuery. It's a large-scale data warehouse from Google with a lot of buzzwords in the name. But basically what it means, it can run queries, SQL queries on enormous amount of data really fast in a matter of seconds.
Can you show me what that looks like?
Yeah, so it also happens that BigQuery has the entire open source code from GitHub as a dataset that we can query. And let me take you to my laptop where I can show you BigQuery in action. Oops, spoiler. Another spoiler. Yeah. So this is basically BigQuery, and I have a query here. I'm going to run it in a moment. You can see it's going to, no, I didn't want developer tools. I wanted full screen. You can see it's going to process 2.3 gigabytes of source code when I run it. So I'm now clicking the run button, and now it's running in the cloud. Like, it's going to take 1 minute.
So wait a second. Is that just SQL?
So
like
yeah,
the SQL we would use for databases?
You can recognize here some SQL elements like select, from, or where, but BigQuery has this interesting feature where it can also run JavaScript as part of your SQL query, as you can see above. So
I love that.
basically, we are using the TypeScript compiler inside BigQuery to process all the source files, find all the methods and functions, and extract the comments and the bodies of the functions and methods.
I see. So we use the TypeScript compiler, which we take advantage of the AST to then find information we need from those files, such as the function and all these things.
Right, and we do this like in the cloud really fast. It's going to finish in a few seconds. And if you are not familiar with the AST abstract syntax tree, you can find it in a talk I gave with the same title on Angular app. So we have the results. Table with basically the comments and the text. Check if we should attach. Let's go to the last page, see if there is anything interesting there. So basically we have here, let me zoom in. We have here 300,000 comments in our dataset.
In just a minute.
Yeah, wow, this is like really long comment. Oh, método que envía a filtro. This is español. Hablas español.
Oh, sí, yo hablo español muy bien.
So we have this large dataset now, this big JSON file with 300,000 comments and functions. Are we ready?
No.
No.
No, I'm going to stop you right there. We're not done yet. We have all the data. That's great. But the next step is actually to clean the data, because the data, well, it's text, right? And we have to do a couple of things. It's not as tidy as we want it to be.
We've seen some comments in Spanish.
Yes, exactly. And that's why the first step would be to turn everything into lowercase, because we want to remove the noise from the data set. We also remove URLs, because that also just adds noise to the data set and has no added value, really. We also remove non-English comments, because we know that already learning one language is difficult, right? And then learning all these languages would be even more difficult. And then also, again, to reduce the noise and complexity, we replace function names and arguments by just very generic placeholders. And we also do that on an AST basis.
So basically, the comments no longer contain the function names and arguments. They just contain function name placeholder, argument one placeholder. So it's easier for the model to understand that a specific word in the comment is actually one of the arguments of the function. And once we have done cleaning, we start cooking.
Almost. It's
Okay.
like preparing dinner. So it's like a recipe, and you have certain steps and things you have to do, right? If you want to make a tomato soup, you have to, cut the tomatoes, and they have to be in a very specific shape for a tomato sauce or soup. So that's what preparing is all about. For instance, we have text, and obviously machines, they don't work with text.
Right.
They work very well with numbers. Exactly. So that's what we have to do.
We have to take the text of the comment and convert it into a list of numbers. So we create some kind of a dictionary, like you would have an English dictionary, but in this case, it's not English to Spanish, it's English to numbers.
And also the other way around, so it's both ways.
So when we feed the input into the model, we use this dictionary to convert it to a list of numbers, and then when the model predicts a comment, we use the dictionary again to convert the numbers the model predicted into text.
That's right.
That's right. So are we ready to train it?
No.
Why not?
Not yet. So we have to come up with a model architecture. There's a couple of things you can do. But for training a model, you would typically use Python, as we already mentioned. And there's a library called TensorFlow, which lets you train and create these models. And you can think of TensorFlow as like this box which with a lot of Lego blocks. You can think of these blocks as Lego blocks. And you can just mix and match them and stack them on top of each other to build the model you need.
But how do you know how to do this?
Well, you would look at very similar problems. You wouldn't start just from scratch. You just look at very similar problems from maybe other problem domains and then use the same model architecture.
Which problem is similar to generate comments from code?
Well, think about it. Maybe translation. What if I want to translate German into Hebrew? That's kind of the same. We want to translate code into English.
I know how to say something in German. I will do it live, translating Hebrew to German.
Okay,
so
try.
The Hebrew one is Yesh li tzipo.
Yesh li tzipo. And
Yeah.
which means I have a bird.
Yeah, so in German that would be Ich habe einen Vogel.
Yeah, you could say that. I wouldn't.
All right.
Anyways, so what you do is you look at very similar problems and then you can start with models you already find, try to tweak them and stack these building blocks. We're not going to go into too much detail here, but that's basically what you would do.
Yeah, so we just took an architecture called encoder decoder, implemented it in Python. You could find it in the repository. We open source everything, unlike Asim. And then let me show you how we train this model. So we could install Python on our computer, but that wouldn't be the way I would recommend to somebody. Oh, the training, yeah. That wouldn't be the way I would recommend to somebody who's just getting started with machine learning to do it, because setting up your computer is like half a day of work. Fortunately, there is something better. It's called Google Colab.
It is awesome. So if you know StackBits, it is almost like the StackBits for machine learning. I mean, it's not really a code editor, but you can think of it as StackBits for machine learning.
Yeah, so here I have my Colab worksheet, and I'm going to run these commands. You can probably see that I'm cloning our repo. So it runs these commands now in some machine somewhere in the cloud, and cloning our code, and also copies a small data set. Let's have a look at the data set. So this is what we are going to feed to the model. It's a super small data set with just 5 functions and their comments. The functions have been translated to more complex for us, but simpler for computer representation, called the abstract syntax tree. And then there you have the comments, and you see that we replaced some of the text with argument number 1, arguments number 0, etc. That was the preparation.
Obviously, those information are very important to predict meaningful and correct comments, but for the first step of this model, we just replaced them just to remove all the noise and to reduce the complexity.
Fine, so we downloaded the code, the model, and we can run ls-l to see, we need a exclamation. We can run ls-l to see the list of files on the remote machines, and we can see it has all those files from our repo. And we are going now to run the training script. That would take probably a moment or two. So basically right now, what are we doing?
So we just started the training process, and as we can see, there is something called epoch 1 of 5. And this epoch is just another name of iterations. We have a data set that contains 5 sets of abstract ASTs and the comment for that function. And one epoch is going through all the data points, data entries we have in our data set. And the training is really just an iterative process going through all these examples over and over again until that function, this model, produces, well, somewhat good results on a variety of inputs.
Right. So it's almost done, and while it's working, we have trained it in Python, right? But we do need to figure out some way to get it into JavaScript.
Yeah, I mean, we can run Python
In the browser.
in the browser or from within JavaScript. That makes
Right.
no sense. So we have to come up with this missing link in between. And I think we've already mentioned something that we can use, right?
Yes, so basically there is a TensorFlow.js, which is TensorFlow for JavaScript. And we have one more thing we need to do so we can use our model inside TensorFlow.js, which is basically convert it into a JavaScript model, which is a JSON file. So here I'm running this script to convert the model and create a zip file with the model that has been exported.
You can think about this as, remember that this model exists and that the machine somehow comes up with this implementation. This is what we basically do. We export and convert the implementation of this model, this function, to a format that we can easily consume from JavaScript.
Yeah, and the implementation is just a bunch of numbers. We can download a zip file. Wow, that's fast. And I would have extracted it, but I already did. So do you know Wallaby.js?
Yes, it's an awesome tool that really allows TDD.
Yeah,
at
but
its best.
We are not going to use it for DDD. We're just going to use it to test the model we just downloaded. So we created a small NPM package called the TS comment predictor that has a new comment, export a comment predictor class that knows how to load this model using TensorFlow.js. So you can explain what I'm doing while I'm doing it. So first of all, we need to load to create a predictor.
He's already explaining it.
Comment predictor, Nikuda load.
I don't have a job. So yeah.
Sorry.
We wrapped everything, all the TensorFlow.js stuff in an abstraction. It's a thing called comment predictor. We're loading the model that we just saved and converted into JSON that we can easily load it. And that uses generators, JavaScript generators, and now, what we do is create a function, one example that we want to feed in, that is the input to the model. And it's just a string, right? And then in the next step, awesome function. Technology plus is awesome. Good.
Let's console log the result of running the predictor.predict with the function code.
And we're feeding in. What do you think is going to happen? Well, hopefully it produces some comment.
It's thinking, you see.
Let's see. Remember, this is a very, very, very small data set. It was only 5 examples. And, well, do you think that the results are going to be good or bad?
Or no results at all?
Or no results at all, because machines never work?
Yeah, it seems like my computer is tired. Let's give it one more try. Maybe it should be, it doesn't like this kind of text. So yeah, our model is lazy. We created a lazy model. What have you done?
Just like us, I would say.
Oh. Yeah. Anyway, so to be honest, this model was not very impressive. It wouldn't do a lot of stuff because we only trained it on 5 functions, and apparently it's also lazy. So it will probably predict some nonsense. But
maybe that's a sign. Maybe it says there is no comment because
there's
no comment.
Yeah, there is no spoon.
Oh,
now it worked.
Woo!
And as you can see, it's not very intelligent. What it says is technology, 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 technology.
TT. Very important.
Very important.
TT. That's typically how I end my comments as well.
This is still a little bit impressive because the model did learn that there is slash and star in the beginning of comments and space between words, I guess.
It has learned something.
From 5 examples, not too bad.
All right. Let's take a look at a real thing.
Yeah, so we trained a model for an hour on a dedicated, Google has this dedicated machine learning hardware called TPU. So if we train this model regularly on our own machine, I did it overnight. It took 7 hours just for one iteration. And we had to do hundreds of iterations in order to get it good. But with the TPU, it takes like 5 seconds.
My machine dies. I can't do anything else if I start the
So
train.
yeah, definitely do it in the cloud.
Yes.
And once we had this model, and we saw that it sort of works in JavaScript, we wanted to integrate it into a Visual Studio Code extension. So how would you create a Visual Studio Code extension?
So, I mean, I know Angular, and Angular has this thing called schematics, which is scaffolding, right? And there's also this tool called Yeoman. Yeoman, which we can use. It's like a scaffolding tool, and we just say, Yo code.
Yo code to generate an extension. We want TypeScript. We'll call it
Lazy Octopus.
Okay. Just
to match the theme.
Yeah, as cryptic as the Angular release names. There is no description, no repository, npm. And basically at this point, we have VS Code extension create. You see, it writes the code for us.
It's awesome.
Awesome.
This is machine learning.
And as soon as it finishes, we also want to install here our model, and
which we've published to npm, which is great. I mean, everything, all this shows you that it is not that difficult after all to consume these models. I mean, you can publish them to npm, you can use the tools you already know. So don't be afraid of machine learning. You don't have to do all the data science yourself. You can get help for that or have someone that really knows data science. But as you can see, you can easily get started and then be in your comfort zone.
Yeah, you see, just downloaded TensorFlow and it's installing it. And I think if you ever created a Python environment, you would know how much time it takes to get this installed. And here we get it like in 3 seconds from npm. You don't have to do anything, just npm install. And now we have this lazy octopus. We can open the newly generated project in Visual Studio Code. And if we look at the package.json, this is something special in Visual Studio Code extensions. We can see it defines a command. A command is what happens when you open the command palette. So when you create a new extension, you can add something to the list of the commands. So we'll create a command called
add comment to function.
Thank you for dictating this to me. And then we would like to implement it. Actually, let's look at the implementation that comes by default. It should show an information message saying hello world. Let's just do a quick check to see if that works. I'm going to hit F5, and hopefully this is going to build the extension and open. Oh, errors.
npm watch. What is the error say?
Oh, so many errors.
Okay, I would say we skip lib check. So yes, there's a flag in the tsconfig file that, lets you skip lib checks.
Error's gone. Read about it at home. It's magic. This is the real magic. We appreciate that.
That's good.
All right, so now we can press F5, and we have another Visual Studio Code inside our inception. And then we can press we see a new command added, and when we click it, it says hello world.
That is awesome.
So the only thing we have to do now is just to implement it.
Right, we just installed all these packages that we've published to npm, which contain the trained model and the abstraction, so we can easily just implement everything here inside the Visual Studio Code extension. So let's do that.
Yeah, let's start. So I need some utility functions. Let me create these util functions, util.ts. So this is cheating. We just coded it beforehand, but basically these are functions that use the TypeScript compiler to get the current function you are currently looking at in the editor. And we have code that call that functions, basically returns the current element, that's the current node, the current TypeScript element you are looking at, and find parent function returns the function you are currently looking at. So let's do a quick demo of that, where we just display the function we are looking at, get text, and reload this. And now when we run the command, we can see that as soon as we click add comment to function, it activates the extension, and it gives us the function we were looking at, the same function. And
so this is exactly what we need for our model.
Yeah, that's the input that the model will get. Perfect. And let's load the model, right?
Yes, let's do it.
So importing and creating the model from the npm package. And then the last thing we would need to do is we are going to show a progress bar because this is going to take a few seconds to predict the comment. It says predicting comment, and this will call the predictor.predict function, the one that we used in the text, with the function text. And then it will insert that comment at the starting position of that function. So just before the function, the comment will be automatically inserted. Are we ready to see this in action?
Yes, I want to see this.
Okay.
And by the way, this is nothing that we can rehearse because it's machine learning after all, so we don't know what's going to happen.
We are going to run this on this function at time series. Will it work? Predicting comment. What is that?
Satisfaction of a constraint to a function. All of these invocations are errors unless otherwise noted.
What do you say? Shall we try another one?
Creative, I would say.
Okay, let's try another one.
So I would say this, speedy function. A speedy JS function has the async modifiers and contains use speedy.js directive.
It doesn't have async. Let's see what happens if I do add async and run that again. Would that return the same thing?
Well, I would guess. Oh, yeah, that makes sense. Observe returns true when objects are shallow equal. Yes, that's what I would expect from observe, I guess.
Magic time. Let's see if it works.
I hope it's not going to break this time. Ooh! Very nice. Okay.
So I think we can summarize. What have you seen here?
So before we talk about our learnings, I guess there's things we can still improve, and we definitely want to continue working on this because it's just fun and fascinating. So overfitting is a problem. Overfitting means that the machine really just memorizes the entire data set. That's why it's so bad at actually predicting proper comments for something that it hasn't seen. So that's something we should definitely fix.
Yeah, I mean, we only trade on 2,000 functions, so it has a small data set, it can memorize it, but once we go bigger, well, it won't be able to memorize everything, so it will have to be smart and learn.
Exactly, but then there's the problem of memory constraints, because if you have a very, very large data set, you have to come up with ways how to reduce the memory requirements and all these things, so that's another thing we have to do.
Right, but that's not your problem, because I think the important thing here, you can use the help of a data scientist for the data science part. You just need to you can just do the JavaScript integration, like integrate what they worked so hard to create into your applications.
Yeah, and basically what we've seen is that how easy it is to get started with machine learning, even in the JavaScript world, right? We can easily use TensorFlow.js to convert Python models, then integrate them into a Visual Studio Code extension and all these things.
Yeah, and basically, we know that text summarization, which is what we try to summarize the code into a comment, is possible. Like, it's an active area of research, and people are doing it. So we believe that with some more work, we will get perhaps less funny, but more useful results. And we think that tight integration with existing tooling, like Visual Studio Code, is crucial to success. And this is where you come in, where you can take machine learning and integrate it into your environment, your application. And
so I guess the main takeaway is that machine learning is exciting.
And it's coming to JavaScript.
And it's coming to JavaScript, and that you can all get started.
Yeah, so you can see all the code that we created and the commits we did last night and this morning and after this morning and 5 minutes ago in the repository. The slides are here. We'll also publish everything on our Twitters. And with that,
thank you very much.